class, it's Mr. Hofstad here with Unit 3, Lesson 9, which is less of a lesson and more of a review of the Newton's 3 laws, Unit 3, Lesson 2, 3, and 4. So this one's just kind of going over those 3 laws all as one, right, and combining them into a description of motion that you would actually see in the real world, right? Something that's quite familiar with us for sure in the example, right? I don't have a tennis ball right now, but I do have this bright orange golf ball that's nice and easy to see, right? So we're going to analyze just simply throwing up the ball, letting it bounce, okay, and come back down. Sorry, come back up. We're going to look at all the stages of that motion and where each of Newton's 3 laws are coming into play. All right, so for our first stage, Newton's first law, right, that explains when objects are at rest, right, they tend to stay at rest. So we have no acceleration, right, no net force on it. So that's occurring when the ball is just sitting in my hand at rest before I start throwing it, right? And what's really going on here, there's always a force of gravity acting on the ball, right? It's pulling it down towards the center of the earth, and there's a normal force between the surface of my hand and the ball that's preventing it from traveling down, right? So we have force of gravity is equal to the normal force between my hand and the ball, no acceleration occurring, right? But as I throw it up, so the instant that this ball starts to travel upwards, right, it is accelerating upwards, right? So as soon as I throw it up, right, there is an acceleration upwards. So when we have an acceleration, we know we're no longer working with Newton's first law. Now we're working with Newton's second law, and we have to have some unbalanced forces. So here, the normal force between my hand and the ball, or the applied force of my hand on the ball, an external force on the ball itself, right, is greater than the force of gravity pulling it down towards the center of the earth, right? So I'm going to toss it up, right, and as soon as it leaves my hand, right, there's this, while it's in contact with my hand right before it leaves, there's this force applied by my hand onto the ball that needs to be greater than the force of gravity, and those unbalanced forces will accelerate the ball upwards, right? So that's our second stage of this motion. And our third stage, now the ball has left my hand. I'm no longer applying the force of my hand upwards on the ball. The only time I'm applying that external upwards force is when the ball is actually in contact or touching my hand. So as soon as the ball is in the air, airborne, we now only have one force acting on it, the force of gravity. So we call that free fall. The ball is in the air, not experiencing any external force from my hand anymore. The only external force, if we were to draw a free body diagram of this golf ball or this tennis ball in the example, is the force of gravity pulling it down. So as soon as it leaves my hand, right, imagine this hand is invisible, doesn't exist. I'm going to throw it up. As soon as it leaves this hand, the only force acting on it is the force of gravity, right? What law are we looking at here? Still Newton's second law, but instead of the force applied by my hand being greater than gravity, we have the unbalanced force of gravity downwards, nothing upwards, right? So stage 3, as it's in the air, as it's airborne, experiencing free fall, the only force and the unbalanced force acting on it is gravity. So the whole time it's in the air, it's experiencing 9.81 meters per second squared acceleration downwards from gravity. So that's kind of related to what we looked at last unit with our vertical projectiles, right, throwing a ball up and coming down. We know that as soon as it's in the air, it's experiencing gravity's acceleration downwards, right? And the fourth and final step, right, as I throw it up, it's going to hit the ground and it's going to bounce back upwards. So we're going to really focus in on that moment where it hits the ground, right? What's happening there? As it comes into contact with the ground, the ball is going to apply a force downwards into the ground. What's the ground going to do in response? It's going to apply an equal and opposite reaction or a second force upwards on the ball, right? So that is summarized as Newton's third law. So as it hits the ground, there's an equal and opposite reaction on the ground, from the ground onto the ball upwards, right? So the ball will apply a force downwards on the ground. The ground will apply an equal and opposite force upwards on the ball, which sends it bouncing back up. All right, we are losing some energy in that, right, due to the sound that's released, the heat, deformation of the ball, maybe a little bit of the ground, which is why it won't bounce back, right? Also, air resistance, we're losing energy, so the ball will never bounce back to its original release height, right? See, if I start at the top of the screen, it'll bounce and only come about a third of the way up the screen, right? And that all has to do with our next unit, which is coming up next week. So talking about energy for our next couple of weeks here. Exciting stuff, right? So if you have the solutions on your computer, right, or on your phone, they're posted on the Google Classroom. You'll be able to kind of follow through these notes. I talked through them, right? Stage 1, at rest, Newton's first law. 2 is Newton's second law, where the applied force by my hand is greater than gravity. 3, now also Newton's second law, but gravity is the only force, so we have unbalanced force downwards. And stage 4, we have Newton's third law when it hits the ground, and as it starts to accelerate upwards, right, the reaction force of the ground on the ball is greater than the force of gravity, which is why it starts to accelerate upwards. So that's kind of stage 4.5, right? We're getting into a new point of motion. So I encourage you to get those notes down, draw your free body diagrams. Again, this is a review lesson, nice and short, nice and easy. It'll just kind of wrap up everything nicely for the this unit. So I'll see you guys next week to talk about energy, Unit 4. See ya.